RT, I'm going to put S somewhere here. Now if you're like, ooh, I didn't put my S right there, that's okay. It'll be all right. I'll label what I know. RS is 2x plus 10. ST is x minus 4. RT is this whole thing that's 21. What equation did you guys set up here? Yeah, Evelyn, what'd you do? You figure it out?
2x plus 10 plus x minus 4 equals 21.
Very good. So we get just put those together. It should add up to 21. Again, you don't want to set them equal. We don't know for sure that they're equal. Actually, don't think they are. So we're going to combine our like terms. Now, on the same side of the equal sign, some of you guys, the algebra piece of this is kind of the most difficult part for you. We're combining those together. So 2x and 1x is going to be 3x. 10 minus 4 is going to be a positive 6. So when you're on the same side of the equal sign, you don't change any signs. But now, when I go to move things around to the other side, that's when I have to undo what's happening. Now, I don't think you necessarily need a calculator for this, but just a reminder that please bring calculators on Monday. Please don't assume I have them for you. So x ends up being 5. And then we can find the length of each of those. So actually, I find out my drawing is really awful because this is actually 1 and this is supposed to be 20. And that's okay, like that's, I mean, it's not my drawing had to be perfect by any means. I was still able to figure this out despite having a really awful drawing. All right, the next one, example 2. What's another name for xy? Another name for xy. Well, go ahead.
R.
Oh, we're looking at this here.
Yeah.
Where is there an R?
Well, come on.
Do you see?
Yeah.
Unless you put an R on there.
Yeah.
Let's not add stuff. Let's go with what we got here. Because we all don't have an R. Yeah, what do you think, Evelyn? YX. You could call it YX. What if I wanted to kind of change the name a little bit more, be a little bit more unique? Is there another name that would still work for this? Anyone got it? Yeah.
XWY.
You only the 2 letters you need. So XW is enough. Because it's a line, if I go through W, it's automatically going to keep going through Y. So these names are all okay. So you can keep going through that same line and it's still that same line. So the XW is still also acceptable. And so would WY would be okay? And then obviously the flipped versions of all those. 3 points that are collinear. Last one kind of gives it away. It's all the points we were just talking about. X, W, Y are all in the same dot line. And maybe, Lena, this will help you with your idea of the coplanar idea. So give 4 points that are coplanar. Well, maybe we'll talk about non-coplanar too. So 4 points that are coplanar. So I can use these, and then what do I need to add to it? What else has to be with these? What other point has to be included here, guys? Yep.
Q.
Q also. So X, W, Y, and also Q. Now, if I want a non-coplanar, so just to kind of make that, then basically, if I said 4 non-coplanar points, all I have to include is 1 point that's not coplanar with the rest of these. So Z, as soon as I include Z, that already is going to make this group non-coplanar. X, W, Q, any of those, the minute you put Z in that group, it automatically makes that group not make sense. So that'd like be me walking into a room and saying, I'm gonna assume you guys are all freshmen. And some of you guys are like, hey, wait, no. And I'll be like, no, but most of you are. Like, you know, like that's not the case. The fact that we have people in here that make it not freshmen anymore, then that changes the rules. So the minute we throw in that other point that's not on that plane, this group becomes non-coplanar. This is not an all freshman group. So you may have a class where just one non-class member is like a different class, and it's like if the teacher refers to them all, hey, freshmen, I'm thinking the sophomore or junior in that class would kind of be like, what? Like that wouldn't be okay. So same idea. Z is kind of like, no, I'm not on the same plane as those. All right. So find PQ. So what are we doing in example 3 here? What are we setting this up as? It's not like the last one we did. We don't know what the whole thing equals. What can we do in this case? What do those tick marks mean, you guys? Yeah, Will?
2x plus 35 equals 5x.
Yeah, those little tick marks tell us that these are equal. So that means these two are equal to one another. So 2x plus 35 equals 5x minus 22. So now to move that x over, I have to undo it because it's moving to the other side. Move this 22 over. Then I'll divide by 3. Is it 19? Did anyone get this yet? For x?
Yes.
You got it? 19? No?
There's
Yeah, 19. That's just x. Yeah, you have it there. So x is 19. But then they want us to find out PQ. They want us to figure out the whole line. So I can do 19 times 2 is 38 plus 35. So this is 73. If that's 73, this one's also 73. So do you get 146 for that whole line? Yeah. So PQ is 146. And stop me if I'm going too fast, or obviously I'm not going to tell you stop me if I'm going too slow, but let me know if you missed something, why we did something that we did. All right, so in this problem, they tell me to find the measure of LHJ if KHJ is 90 degrees. So they're telling me that this is 90. So how are we setting this one up? Yeah, Evelyn?
4x plus 7 plus 8x minus 1 plus 1.
Yeah. And I'm just gonna, because I started writing the 8 first, but yes, you're right. You can also write it that way. You just reverse the order, it's fine. I just started with my 8. So this one, they're gonna equal 90, because they tell us it equals 90 together. They might use a word like perpendicular, they might use a word like it has a right angle, they might say complementary, all those different words could tell us the same thing. 12x equals 84, right? Yeah. And then divide by 12. What do we get?
7.
17?
No, it's just 7.
Oh, 7, yes, thank you, sorry. Trying to make that too big. 7. And then they want the measure of LHJ, so we're going to put that back in here. ended up with 35 degrees there. All right, the next one they tell us of an angle bisector. Angle bisector, remember, breaks into two equal pieces, or two equal angles, so those two would be the same. They're the same, what can I do with them? Set them equal. Now this one is a fraction, so that might kind of throw you off or scare you. If you'd rather work with decimals, you could change that to 0.5. If you want to get rid of the fractions, you could do that by multiplying everything by 2, like doubling it. Or you could just work with the fractions. Any preference on what we do? Decimal, you just use decimal. Doesn't really matter to me. I'm going to move this one over the half. So 1 minus a half is going to be a half, or 0.5. Now this you might be able to just look at it and know the answer. Or you could divide by 0.5, you could divide by half in your calculator, you can multiply by 2. I like doing that just because that's easier in my opinion to think about. So x ends up being 100. And then they want the whole thing. So I can find half of it. So this will be 50 plus 17. This is 67, this is 67. So we get 134, I think. For that angle. Big angle. And then we have just flip it over, we have a couple more examples, almost done here. I know it's been lots of notes, just trying to make sure you guys are feeling ready for a test. If you guys have questions, feel free to bring them Monday morning when we start. That's fine to ask questions before we start. Now, if you come in and say, I don't understand this whole chapter, then we have like probably an issue, so making sure that you guys are, like if you need a lot of help, then you should be like staying today or something, popping by after school. All right. So this drawing, hopefully, is it easy to see on your paper? Can you read the numbers? Yeah, it's not too bad if you have okay eyesight. If you have bad eyesight, sorry, it's not the question for you. So they tell us that this is 142 up here. Then they tell us that this is 53 there. And then they have some stuff marked for us that they wouldn't even have to have marked. But, so, guys, raise your hand. Tell me something you know on this drawing. Fern, what'd you label? Tell me one of your angles that you know.
I had a.
Is what? 38. So Torrin has A is 38. And I'm assuming he got that from the fact that A and 142 should add together to give us 180. So long as he can subtract and get 38, it's a really easy one to mess up with borrowing and stuff like that. So 38 is right. Somebody else give me another one they know. Another angle you know in this drawing. Julie, you have one you know? C would also be 142. It's across from 142. So C would also be 142. And what does that leave us for B? What's it? Broken calculator. That's not B. B is going to be what? Yep, Evelyn? 38 as well. So again, we can figure those out from either vertical angles or linear pairs. They kind of all can help us in those cases. And we have D, E, and F. And this one, they kind of mark some things for us, which is kind of nice of them. They don't really need to do that. Which one do you guys know? You get Reese. E is 53. Again, they wouldn't need to make those marks. They did for us, which was nice of them, but they wouldn't have to. We should know that that's 53. And then D and F requires a little bit of work. Michael, what'd you get?
37.
37, and how'd you figure that out?
I added 53, and then there was a right angle. It was 90, so I added those together and subtracted it from 180.
Yeah, so you could do so kind of what he's saying is he did this whole straight line. Otherwise, you can also know that those two together are also 90. So both of them get us to the point where we have 37 for each of these. So again, that happens because they're across from each other. And then finally, our last question. The other thing, it just says formulas to know. Again, we put those on our blue sheet already, so this is all we have left, and then you guys will have the rest of the time to work. Sorry for talking a lot, but again, you guys hopefully ready to do well on your first test. I didn't do a distance and midpoint example on here, but there will be some in your homework, and we did that Kahoot. Are you guys okay with that? Or do you need a distance and midpoint example? I can always put one on here if you guys decide. So let's go through this example first, and then if you want one, I can always put it up here. So A and B are complementary. What does that mean for us? 90. So think 90 when you see complementary. So that means these two together add to 90. Are these the same measures on the front side? No. I feel like we already had done these numbers, but. So together, these can add to 90. You can even add them the way they are. So 3x and x is 4x. 2 and negative 4 is negative 2. That should add to 90. X ends up being 23, is that right? Okay. So x is 23. They want the measures of A and B. I put that back in. 23 minus 4 is 19. And then that leaves the leftovers for angle A, which would be 71. Does that sound right? All right. So that's the gist of what's going to be in our test. Again, so the problems you see here, anything like that could be up for grabs. Also, the review you guys are going to be doing is homework that's listed there. Anything like that could show up on our test. Again, the only thing I didn't do an example of is distance and midpoint formulas. Anyone want an example of that? Yeah, so, okay, so if you don't need one, feel free to start working on the review that's listed here for you guys. The pages should be live now on Schoology. I'm gonna do a distance and midpoint. I'll do an example of both. So if you'd like one, follow along. If you don't care or don't need one, just find it working quietly is fine. So I'm going to do distance and midpoint of these 2 points. And so again, the distance and midpoint formula you guys want to have memorized. Of these. So distance, I'm taking the x's and subtracting them. So I'm doing 6 minus 5. And then I have to square it. Plus, I'm doing the y's and subtracting them. Negative 1 minus 10, and I'm squaring it. Are you okay with why I have the numbers where I have them? And you just have to be consistent about your order. So 6 minus 5 is 1. I'm gonna square that. Negative 1 minus 10 is a negative 11. I'm gonna square that. 1 squared is just 1. Negative 11 squared is gonna be a positive 121. Again, this is why we want our calculators, because this is not gonna be a nice number. We end up 122. I'm going to take the square root of that in my calculator, and I get about 11 point something. Again, Anyone do it? What'd you get? 0.04. Oh, so almost like exactly 11. So not quite though, because 11 square root of 121 would be 11. So that's our distance. And then our midpoint is now we're going to take the x's and add them together and divide by 2, and take the y's together and add them and divide by 2. So now this time I'm adding these together, those same 2 points. And you're going to end up with a coordinate. And you can just leave it that way. Otherwise, if you want to write it as a coordinate point, 5.5 and 4.5 is fine as well. And that's it. Distance is a value. Midpoint is going to be a point. Okay. But so your homework is listed there for you guys. It's out of the book. I took the pages already. Notice there are some all, so like doing odds and evens. I know. So online students, if you need help, send me a message. We'll kind of a live meet